Alright, so this is mini project number 2. We're drawing an icosahedron, which is basically 20 triangles nested together with circles inside it, and we're also supposed to put a random walk starting in the center of each circle. Now, I didn't complete everything in this assignment, but I was able to make the icosahedron and write a good function for random walks. So the first thing that we have to do is import these 3 modules: math module, turtle module, and random module, because we're going to need all of them for this program. And then set pi to be pi, because we're going to need that one. Now these next 3 are trig functions, and they're exactly the trig functions they look like. You have to put theta and radians for all of them, because that's just how math module is. Now, the whole basis of this program is an equilateral triangle of side length s. Now, this function rs is if you want to draw a circle inside it, which we do, touching, each side on the inside. This would be its radius if the side length of the triangle was s. The radius would be r. And then mass s is just the height of an equilateral triangle. That you'll see why that's useful in a minute. Now, this function can draw. This is try ls and try rs. Now, they each draw an equilateral triangle. One draws it counterclockwise, one draws it clockwise. Hence, left, right. And I'm going to demonstrate for you below. Okay, sometimes it does that. See how it draws it? It draws a triangle at least. Clockwise. Oh, actually, I wrote the wrong function. I was supposed to just be the triangle part of it, but you've seen the next function, tricirc, which is the same thing except it draws a circle inside of it, and I'm gonna show you its cousin, tricirc L, just to show you. We gotta import math again. Not math, turtle. And see, the difference is that time it drew it counterclockwise. Now, actually, I feel like you should see the triangle thing. Yeah. I did the clockwise version. I mean the counterclockwise version. It could have done a clockwise version, so I just wanted you to see that. Now, that should help you understand the basis of how tricirc R and L works. Now, if you notice, these 2 functions are structured almost exactly the same, except for this line in tricirc R versus tricirc L. Because if I didn't do that, it would look like an ice cream cone instead of a circle inside a triangle. Because the turtle, it veers left, like the radial accel would be left if it was a circular motion problem. So you have to flip the turtle. That's the purpose of this line. So anyway, our next function is called diamond buoy, and it makes a diamond shape. It does 2 of those tricirc things, the triangles with circles inside them, to make a diamond. And it's called buoy because it's running like it was floating on wire. It's running horizontal, and the name just stuck. So I'm going to show you what this one does. And we have a diamond. Okay, now this next one is called triquad. The tri is for the triangle things, and the quad is because 4 of them. That's together, so it's a row of the icosahedron. So again, I'm gonna demonstrate for you what that does. Okay, so I've got it going, and it's basically 2 diamond buoys but put together, as you can see. And I set the side length to 150 instead of 100, just to show you that I can. But that's what a diamond buoy does. But we need to do 5 of these things, so we're gonna need to do a little more math. Now, we have to make a vector, because we're gonna pick up the turtle and jump it to the beginning of the next row, if you follow me. So the distance that it has to jump is calculated by this. So y equals 3/4 the side length, and x is 2.5 times the height of the triangle. And you can I'm not gonna prove this to you, but you can visually prove it to yourself by taking the picture of what we're supposed to draw and you know, eyeballing it. And it finds a hypotenuse, and if it were a triangle based on the coordinate system of the turtle module, there's the y component of the vector, there's the x component of the vector. That makes any sense to you. Now, I'm going to define some functions so that we have the direction as well as the magnitude. Okay, so I said it's a vector, right? So the angle that it's going to have to jump is this th in radians below the negative x-axis. And this nose function, it converts to degrees, which is with this, and then the purpose of this line is to make so that it's with respect to the positive x-axis instead of the negative x-axis, the angle at which it points. And it's called nose because when you fly a plane somewhere, you point the nose in the direction that you're flying it. So it's as if the turtle took off and landed, you know, some distance away. The distance of long s away, to be exact. Now, I know that explanation was kind of confusing, but the use of all this stuff is for this function. This draws 5 of the triquads, remember them? To make the full icosahedron. And it's 5 rows because it's called 5 rows. Now if I arrange 5, because you're doing this 5 times, triquad S, so a row, turtle dot pick up, to pick it up, orient it, turtle dot set heading nose, okay, so that's the angle, and then you jump it, the distance, long S, you get it, and then you put it down. And when you're down, you're at the beginning of the next row. That's why I went through all that trouble, so I could do that. And I'm going to show you what that looks like. Okay, so I've initialized that function, and it's making the first row, and then jump, long S, and it's making the second row, and we're just going to watch this thing do its thing. Jump. Now that jump, every time it jumps, that's the vector I was talking about earlier. See, and begin vector, end vector. So it's about to make 5 lines. And this is an inconvenient way to have the screen, but this is what the full shape looks like at the end. Okay, now for another part of it. This is a disjointed and incomplete assignment, but besides the icosahedron that I just made, I was also able to make a random walk. So here's the helper function. First, we've got ranth, and ranth is for random theta, so it just generates a random degree, anywhere from 0 to 360 in increments of 5 degrees. And then rand ds, ds stands for distance or displacement, and the doc screen explained this pretty well. It's a dice for distance amounts. You know, like you go 200, 10, 5, you know, for it's the length of a line segment. Okay? And then Randy Max stands for random integer. Same thing. The max is the highest energy it can generate. So if this were, say, a dice to play dice with, you would say 6 for max. And then deg to rad just converts the degree amount to amount of radians, and these are all going to be useful for the function that I'm about to show. This function is called randBehave, and it's what it is a random walk that when it's done, the turtle returns to where it started. So I do that by means of a sum accumulator. So imagine that the random walk from beginning to end is just the hypotenuse of a right triangle, and x is one leg of that triangle and y is the other leg, and it's a sum accumulator. Okay, so that each time the turtle makes a move in its random walk, it gets added to one of the hypotenuse, and it's basically the x and y components of its walk, if that makes sense to you. And in Randy 13, so that it'll take a random number of steps. It might take 5 turns, might take 7 turns, might only take 1 turn. You know, but it'll be less than 13, so it's manageable. So random angle, convert that angle to whichever one, I forget. And then do a random displacement, and then set the turtle that random angle and walk it for that random distance, and then add it to the sum accumulator, and then this part returns it to the thing. And I've been rushing through this in the interest of saving time, but I'll give you more detailed notes in the document. But oh, by the way, the S is the same thing as the side length of the triangle that I've used. It's a proportion. Is to make it proportional. That's why I chose to do it that way. And let's see, rand ds is the maximum distance, minimum distance, and the step. So that's what these parameters here mean. Sorry I glossed over that, but I'm gonna show you what it does. Alright, so you can see it doing a random walk, and then it returns. So that's my video. That's as far I got, and I'm sorry I've glossed over everything, and I'm sorry this video dragged on too long, and I'm sorry that I didn't complete everything, but there'll be more detailed explanations in the notes, and thank you. And that about does it.